PN junctions consist of a P-type semiconductor connected to an N-type semiconductor. There's a boundary between the two types, and diffusion of electrons occurs from the N-type to the P-type. We can see this more clearly if we look at the band structures. The band structure of the P-type consists of an empty conduction band at higher energy level and a lower energy filled valence band. And then sitting slightly above the valence band are discrete energy levels that are empty. For the N-type, we have also an empty higher energy conduction band and a lower filled valence band, but this time we have discrete energy levels slightly below the conduction band, and these have electrons in them. So when we put these two together, we have electrons in higher energy levels and holes in lower energy levels, and so there's a natural diffusion of electrons from the N-type to the P-type. But at the beginning, these two materials are neutral, so this movement of electrons creates a negative charge on this side of the boundary and a positive charge on this side of the boundary. A consequence of that is that no conductivity can occur through this boundary. The reason is because the P-type conducts by virtue of promoting electrons from the valence band to the discrete acceptor levels, and that cannot occur when there's an excessive charge in those acceptor levels that is created at this boundary. On the N-type side, the N-type conducts by virtue of promotion of electrons to the conduction band. But with the movement of electrons diffusing across this boundary, there's an absence of electrons that can do that movement to the conduction band. So what we have is we have our PN junction with the P-type and the N-type, plus our charges at the boundaries, and we can have no conductivity through that boundary.